session of assessing farming systems at different scales. And yesterday we had some very interesting talks dealing in particular with rice, whereas this morning we had a broad array of different topics we dealt with and that were presented. This afternoon we have also again quite a broad range of topics, and we start with somewhere it's all about looking at organic farming systems and some of the aspects related to that, again from different parts of the world. And we start with the first poster stream of the first presentation by Stephanie Domptail on agroecology and organic coffee. Where does the organic matter come from? A resource accounting approach. And after that, we have time for a few questions, which can be raised on the Q&A session portal of WUVA, from where I will hopefully collect them and then raise them forward to the speaker. Stephanie, I think, did you send over a pre-recorded version?
I have. Can you hear me?
Yeah.
Okay, great. I did, but I'd still prefer to tell you live about it because I think it's more fun. But you can, yeah.
Okay, then I would suggest that you share the screen with us now with your presentation, and you do it live. You have your 3 minutes, and as soon as you share the screen, time is running, and I'm looking forward to the presentation.
Okay, I will just make one more announcement, is that unfortunately my presentation file has damaged in the transfer, and I have just noticed now. So I'm gonna have to share with you the PDF of the poster itself. This is not what was planned, but it's, I think, better than nothing, and I think live is still.
That's fine. Just
maybe okay. So let's
share your
start.
screen. Off we go.
Okay, so I think you see that. The first thing that I want to acknowledge is your presence. Thank you for being here this afternoon, and also for giving me the opportunity to talk about this research. I'm doing this work from University of Gießen. My name is Stéphanie Domptail. My colleagues at the University of Gießen are Pardis Amin Javaheri and Ernst August Nupenau, and from the University of Makerere, Christopher Sebata and Janina Karungi. So our research on intensification strategies builds upon the work of my colleagues at Makerere University, who have identified the coexistence of the organic and the conventional intensification strategies in Uganda. In the Mount Elgon region, you see the picture up here. So we were wondering, of course, why these two intensification strategies coexist. So we decided to look into more detail at each intensification strategy. Now, this poster is only today about the organic one as a first step in the analysis of our data. So what I want to show you, oh, I cannot move it this way. Okay, then I won't. But here you see on the right-hand side sort of a graph with representation of a farm. This is the method that we have used in order to make an analysis of the metabolism of a farm producing organic coffee. So we looked at all flows that come to the farm, that are within the farm, that go out of the farm in terms of material, energy, and actually also financial flows. We quantified that. Our question behind that was to understand how dependent is the organic production on inputs from outside the farm, and how regenerative is the farm to the environment. And the background behind that is the hypothesis that maybe there is not enough organic matter in this very densely cultivated area to really intensify or to practice organic agriculture, or where to find the organic matter. And so one way of representing results is to make such a figure. This figure is only showing biomass flows. So it's a kind of a metabolism of the farm. The farm borders is here showed by the black line. And so what we could show here is the relation between the farm, its environment inside, and the outside environment. We found that 1/3 of the biomass that is used for the farm to produce, basically, comes from outside the boundaries of the farm. And most strikingly, a large part of the manure, 2/3 of the manure, came from a distant area. And this distant area is down the hill of this mountain, Mount Elgon, in the savannas, where you have extensive rangelands and where another type of cattle is kept. So that was a very interesting coupling that we noticed. The second result was that exports in terms of biomass were less than imports. So we have reasons to think that there is actually an improvement in terms of biomass, at least on the fields. But this is localized, as often, fields that are close to the homestead are receive much more manure. But also this is because this is where the organic coffee is. For the other crops that don't have an organic market, manure is not used, but fertilizers are used. So it's really an intensification strategies that is related to the markets.
All
Yeah,
right, Stephanie, I'm afraid
okay,
we must come to an end now.
sure. I didn't hear the beep beep, but
Oh, sorry.
basically what we want to highlight here is the coupling of two different regions that enable, so the plains and the mountain, and that together enables the production of organic coffee. So it's a solution for a bottleneck in terms of biomass, which is not available to everyone. And yeah, that's it.
All right, Stephanie, thank you very much for sharing your interesting research and some insights into matter flows. And it's time for questions. I'll quickly check the Q&A session if any question came up already. No, I can't see anything. But of course, I have a question. Often in organic farming systems, we have some issues with available nitrogen and phosphorus. Do you also consider this in your substance flow analyses to look at, let's say, the import of nitrogen, phosphorus, the efficient use and export?
Yeah, thank you. We don't. I mean, I didn't, but we are working in collaboration with colleagues in Macarere. And so they have included our exemplary farm in their sample where they are going to trace nutrients and phosphates as well. Sorry, nitrogen and phosphates as well.
All right, thank you very much. Is there any question from the other speakers to this talk? I'll have one more question.
Sure.
How do you deal with data uncertainty? So how reliable are these data? You give exact numbers. So
Yeah, in
what is the
tons.
error?
In
What is the
tons
error?
dry matter. So I mean, we do have a little bit of space. I didn't give 3 points after the comma here at the top, but you may not see I give a few data collection techniques. The data is of course essential and is very, very difficult to get reliable data. At best, we would have actually an anthropologist staying in the farm for a whole year to really document labor inflows and exact use of inputs, sales, etc. Because of course, nothing is documented on a written basis in farms there in Uganda. But what we do is that we try to triangulate. We have other researchers going on in the area, so we triangulate the yields data that we have with other researchers that have worked here. We use observation, we use interviews, we do own measurements of yields, etc., as much as possible. Yeah,
Okay.
and we have to correct many mistakes.
Yeah. Thank you very much. I think we should move on. Again, Stephanie, thank you very much for a very interesting talk here.
My pleasure.
And we stay with, as I said, the organic farming topic, and we move on to the next poster presentation by David Bautzer. And I think this is a pre-recorded version, which we're going to show. And after that, we have some time for questions. So if you can please start the video of the pre-recorded presentation. So I think you have to unshare your screen, Stephanie, and then it should work. Otherwise, you. Okay, here we go. All right, here we go.
Good evening, ladies and gentlemen, and thank you very much for attending my poster presentation on the topic crop productivity and contributing factors in organic and conventional farming systems in Kenya. Today I want to show you results from our two long-term experiments in Kenya. which were established in 2007. The long-term experiments are located at Chuka and Thika, which is in the central highlands of Kenya, and they mostly differentiate because of their soil fertility and the weather conditions. At these two trial sites, we comparing organic and conventional farming system in a maize-based crop rotation, including crops like maize, baby corn, kale, cabbage, Swiss chard, French beans, or potatoes. We compare the organic and conventional systems at two input levels. We have a high input level representing the export-oriented large-scale production, and low input level representing smallholder production mainly for domestic use. The levels are mainly differentiating because of the amount of nutrients supplied and supplementary irrigation. The conventional system receive mostly synthetic fertilizer and pesticides, whereas the organic systems only use organic fertilizer and biopesticides. Our results show in general that the yields were higher in Chuka compared to Thika, and that we have higher yields in the high input system compared to the low input system. However, when we have a look at a comparison of organic and conventional yields, we see that there are some crops like grain maize, common beans, or Swiss chard, which show similar yields in organic and conventional systems. However, when we have a look at crops like cabbage or kale, French beans or potato, we generally found lower yields in organic compared to conventional. The pest and disease incidence and the water management of the systems. We know, for example, that the high input systems perform better than the low input system because of sufficient nitrogen and phosphorus availability and the supplementary irrigation, which we only have in the high input system. Another major point is the pest and disease incidence, especially in cabbage, kale, and potatoes, which is a main reason for lower yields in organic systems, because the commercial biopesticides which we are using in organic systems are not effective. However, besides the lower yields which we, for example, find in vegetables or potatoes in the organic system, we also found positive effects on environmental and human health. For example, we have less pesticide residues in the organic systems, or we have higher soil organic carbon in the organic systems. So in general, we can say that the amount of nutrients which we apply, their availability, the type of water management, and also the effectiveness of the pest and disease control were the major factors driving crop productivity. We can obtain similar yields in organic systems compared to conventional systems, but that really depends on the management. So what we recommend is that we need to investigate more into biopesticide and botanicals for organic production, and that we explore and integrate other best practices known to reduce pest and disease incidence. Thank you very much for listening. I'm happy to answer your questions.
All right, thank you very much, David, for the introduction to this trial and some of the results. And we have time for one or two questions. Quickly check the Q&A again, but nothing shows up yet. So is there any question from the other contributors here? I have a question related to your trial. First of all, since when is it going? You said it's a long-term trial, but I missed maybe since when it's running. And second, what kind of biopesticides are used?
Good evening, everybody, and thank you for the question. So the trial started in 2006 with the test crop of maize. And the actual trial with the crop rotation, as I have it now, started in 2007. So it's now going since 13 years. So we are now in the 5th cycle of our crop rotation. And the second question was on the biopesticides. We're using different products. There are some botanicals which we're mixing by ourselves, which are farmer biopesticides or botanicals they're using. made out of garlic, onions, titonia. Yeah, and we normally mix also a little bit of neem products.
Okay, so based on local knowledge, or
yeah. But there are also some commercial products which are mainly based on neem.
Okay, thank you very much. I think there was one more question from Stephanie. Yeah, please.
Yes, I was wondering about the high input and low input when you were talking about it. And so have you noticed in the low input system that there is actually a decrease over the years in the average yields?
Yes, so we see it in some of the crops, especially when we have drier years, because we don't use irrigation in the low input systems, you have a much stronger effect. But it's also, we have to say, this low input system is mimicking also farmers' practice in the area. So, and normally farmers use less nitrogen than normally is recommended, and that we've seen also over the years. But not only in yields, especially in soil fertility. So you have a decrease in nitrogen and carbon. So yeah, you really have an effect.
All right, thank you very much. I think we have to move on. There may be time at the end to discuss some of these aspects. Otherwise, make the contact here, make the connection. We've got another talk on long-term organic conventional comparison from India. Thanks again, David, for your contribution. And we straight move on with Gurbir Ulla. You want to share your screen with your presentation?
Yes.
And you can go ahead.
Okay, I try. It's also pre-recorded, but if you don't hear the sound, please let me know, then I can play the sound live. Do you see the screen now?
Yeah, we see your PowerPoint. Now you have to start your presentation.
Here you go.
Okay, we can't hear a sound yet, but we see your presentation.
Okay, then I speak. Huh? I was hearing it. Okay, so I'm presenting the farming systems comparison part from India. So this is this program has 3 locations. So Kenya, India, and Bolivia. Kenya we just heard from David, and now I'm presenting India, where we have a cotton-based cropping system with cotton, soybean, and wheat. 3 crops in 2 rotations. Another problem is it does not hear me. Yeah, okay. So we have 4 systems: organic, biodynamic, conventional, and conventional with BT cotton. If you see this image, in the middle strip here is cotton, and on the left one is soybean. So soybean will be followed by wheat, and then the next year we switch the crops. So all the crops will grow every year. This is the data from 2008 to 14. If you see the left figure, there soybean, the yields for soybean were similar in all the systems throughout all the years. So a legume crop like soybean can make its own nitrogen by symbiosis, and that's why it can perform equivalent in organic as well as conventional systems. Whereas in cotton and wheat, we had a yield gap of 20 to 25% in organic production systems. So organic yields were lower than conventional yields. At the same time, the production costs were also lower. So in the right figure, you will see return on investment, that is the return on production costs, or you can say benefit to cost ratio. And there we see that the benefit to cost ratio or return on investment is much higher in organic systems than in the conventional ones, simply because the production costs were lower. Now, it does not, the total revenue of organic farmers might be lower, but it still offers a very good opportunity for them, for the smallholder farmers who do not have a lot of capital to invest on market purchased goods. So in the organic systems, most of the inputs are from the farm itself, and a minimum of that is purchased. So with that, I would like to thank our donors and supporters. So Swiss Agency for Development Corporation, Liechtenstein Development Service, BioVision Foundation, and COPE Sustainability Fund. And all the results and more information on the project is available on systems-comparison.figure.org. Thank you very much.
All right, thanks, Gurbia, for a brief, swift presentation, also on the long-term comparison of systems of organic farming and conventional, in this case from India. Very interesting results here. We have time for one or two questions. And while checking if there's any question coming up in the Q&A, are there questions from the other presenters? At best, just raise your question or give me a note somehow. Yeah, I of course have a question. When we look at yields, comparison of organic farming versus conventional, there's always the discussion coming up, if yields are substantially lower in organic farming, how can it contribute to feeding the growing global population? Now, you also show that the return on investment is larger and likely also the income situation may improve. So how would you argue then for the benefits and also the shortcomings of organic farming in this context, having lower yield, but maybe a higher return on investment, maybe a higher income? How does that contribute to the question how to feed the world?
Well, yes, I mean, one thing in feeding the world is the income disparity. I mean, there is less, the reason of non-availability of food is less the food production rather than the income discrepancy. So if we improve the income of the farming families, certainly we improve their food security. At the same time, these yields that we see here are from our very controlled long-term trial, where we did a couple of surveys in the same area, same region, where we found that the organic and conventional farmers, their average yields were more or less the same. So on farmers' field, the differences are not that big. These are the strictly controlled long-term trials where you see these differences. That's one point. There is another point that most of the varieties of the crops that we are using are from the Green Revolution era, where they are developed for high inputs. And we need to develop the varieties for low input production, for organic production, and then we can also match the production levels.
Okay, I'm looking forward to that. We have no time for further questions, unfortunately, but maybe time at the end to discuss this issue further. And I'd like to thank you again, Gurbir, for your presentation and contribution here. And I'd like to continue with the next presentation, which is also about cotton in India, by Radhika Channanamcheri. Sorry for the pronunciation. And I think, again, it's pre-recorded, so we get it started, but I hope it's not 7 minutes long, because then we have to stop it in between, because we will not manage to have 7 minutes. So, but get it started, and then we have time for questions.
Good evening, everybody. My name is Radhika Chandanamcheri. I am a scientist in agricultural economics, working at Indian Council of Agricultural Research, National Bureau of Soil Survey and Land Use Planning Institute, located in Nagpur district of Maharashtra. Today, I am here presenting my poster on BT cotton technology impacts on agricultural land use dynamics of Nagpur district of Maharashtra in India. The authors of this poster are myself, Dr. H.L. Karbekar, working as a scientist in NBSS and LUP, Dr. N.G. Patil, Head of Division of Land Use Planning, and Dr. Udayabhaskar Kethineni, Senior Scientist working in Indian Institute of Seed Science in India. This work was done as a part of institute-funded project at NBSS and LUP, Nagpur. Let's have a look at the background and objectives of this study. Understanding the temporal dynamics and trends of agricultural land use will help in planning suitable efforts to materialize the long-term sustainable land management goals and improvement in life quality standards of the farmers of the region. In this perspective, we analyze the temporal dynamics of agricultural land use change in Nagpur in the context of BT cotton adoption since the year 2000. Cotton is an important cash crop of India, since introduction of BT technology in India, which can resist bollworm infestation in cotton plants. State of Maharashtra ranked first in area under cotton cultivation in India, which has 34% of total area under cotton cultivation in India. This study estimated growth in area, production and productivity of cotton and other major crops grown in Nagpur for the historical period between 1998-99 to 2017-18 using data from Directorate of Economics and Statistics of Ministry of Agriculture of Government of India. This study used both simple growth estimation and compound annual growth rate estimation methods. Simple growth model used 2 periods and relative changes were estimated. Compound growth rate was estimated by fitting exponential function of growth and estimated after its log linear transformation using OLS regression method. Let's have a look at the results from the analysis. Descriptive analysis of crop production along with compound annual growth rates of area, production and productivity of cotton in Nagpur are presented in table, which shows that the average cotton area for the study period from 2000-2001 to 2017-18 was 84,498 hectares. Relative change analysis showed that 114% increase in the area cultivated under cotton from the year 2000-2001 and average production of cotton over the period was 24,229 tons with an average productivity of 0.2 tons per hectare. Cotton production showed 347% growth and yield growth was 105%. Compound annual growth rates of cotton area, production and yield showed 3.84, 9.27, 3.56% respectively. From perusal of table, it is known that the share of cotton area of both the net cropped area and gross cropped area doubled within 8 years from its initial share during 2009-10. Results of split analysis of growth for the periods 2000-2001 to 2008-9, 2009-10 to 2017-18 and total period from 2000-2001 to 2017-18 is presented here. Decline in area by minus 4.5% was obtained for first period. Growth by 1.98% in production and 6.85% increase in yield was obtained. The second period showed growth by 9.64% in area. Similarly, second period showed a production and yield growth rates of 18 and 7.4% respectively as compared to their lower growth rate values during the first period. From table, it is evident that compound annual growth rates of area of cotton, rice, wheat, gram and red gram showed positive trend during the study period compared to crops such as soybean, black gram, green gram, sorghum and other kharif pulses as they showed a negative trend in their area under cultivation. From results, it is apparent that sorghum area has been reduced significantly during the study period as crops such as cotton and red gram were being cultivated more in the marginal lands of Nagpur. Similarly, negative growth in both production and yield was obtained for crops such as soybean, black gram, green gram, sorghum and other kharif pulses. Let's discuss conclusions of this study. Our analysis showed that the share of pulse crops like black gram, soybean, green gram and other kharif pulses and millets like sorghum were reduced significantly due to shift of cultivable area to cotton and rice. The results showed that major crops of Nagpur district during the study period were rice, cotton and soybean in kharif season and wheat and gram during rabi season. Competing crops for current land use of Nagpur districts are cotton, soybean and red gram based on climatic and market situations. The growth rate of area, production and productivity of most of the important pulses and oilseed crops of Nagpur district declined during the study period except gram and red gram. It is evident from the results that the increase in the area of cotton was at the cost of other competing crops like millets and pulses and there was shifting from diversified cultivation to intensive monoculture due to land use transitions in agriculture.
Okay, thank you very much.
Let
Unfortunately,
me
we don't
thank
have
you all
time for
for your
questions.
patient
If you
listening to
have
my
questions to this presentation, please contact the authors directly. We have to move on to our next presentation by Andres Sherry. We move away from India after moving to India from Africa. Now we're going to South America. Please, can you now start the presentation of Andres Sherry?
Good morning,
which is the
everyone.
next
I'm going to
pre-recorded
show you
one.
the research on the economic performance and greenhouse gas emissions of traditional and organic cocoa farms in the Peruvian Amazon. The objective was to assess the profitability and carbon footprint of cocoa production under traditional low-input and organic productive systems in the Amazonian region of Ucayali, Peru. Our methodology was using the typical farm approach, in which we employed participatory farmer workshops and expert consultation to define farm typologies, input and output flows. With this information, we built discounted cash flow models and assess their carbon footprint using the ISO and the PAS standards. We found two typical productive systems in the region. For the traditional typical farm, we found minimum to no input use, yields of around 700 kilograms per hectare of dry bean, and mainly the variety CCM51. As for the typical organic farm, we found a low inputs average yield, which has low incorporation of organic fertilizer, mostly guano, achieving slightly higher yields of 800 kilograms per hectare, and acquiring a price differential price premium of 8 to 12 cents per kilogram. The financial analysis showed that no case, if we include the opportunity cost of land and labor, is actually economically feasible. And particularly in the organic case, the gains in yield and the additional prices for the certification cannot compensate or do not seem to compensate the additional cost of labor and of the fertilization used for withholding the certification. With regard to the carbon footprint analysis, we built two cases, one with deforestation and one without deforestation. In the case without deforestation, we found a carbon footprint of 0.2 kilograms of carbon per kilogram of cocoa, whereas in the organic, it raises to nearly 1 kilogram of carbon per kilogram of cocoa, which is mostly related to the use of fertilizer and the manufacturing of it. Nevertheless, in the case of deforestation, when there has been recent deforestation for planting cocoa, the traditional case shows an increase in carbon footprint of less than 0.2 to 24.7 kilograms of carbon per kilogram of cocoa, and in the organic, it raises to nearly 22.07 kilograms of carbon. With this information, we included an offset price based on the price at gold standard to hypothetically offset the cost of carbon released in the case of deforestation. And we found that with deforestation, you would need to have a higher price of nearly $0.4 per kilogram of cocoa to offset those costs of carbon, and would make the exercise even less profitable. We identified two organic production models in the region of Ucayali, one which was characterized by higher prices and higher yields. Nevertheless, this model is not widespread in the region, and with the one that we analyzed, which is the most common, appears to be unfeasible. This allows us to conclude that organic production should only be promoted if it's accompanied with technological package that allows sufficient yield and proper price differential. Otherwise, the traditional no-input production would seem to outperform it, both financially and in terms of greenhouse gas emissions. We still have to recognize the financial performance of the two typologies is very low, which signals the vulnerability of the producers in the region and indicates that farmers with access to capital can be incentivized to engage in more profitable productive activities such as rice, which adds pressure to the forest. We found that 99% of the emissions in both models are attributed to deforestation, which makes it a priority for mitigating the effects of mitigating the greenhouse gas emissions in the sector. And we found that the true cost of production in deforested land including offsetting emissions, would increase prices at nearly 35 cents per kilogram, which is 3 times the market price differential for organic production. This means that incentives for zero deforestation products should incorporate equivalent price premiums or compensations if we really want to promote this type of models in the region. Thank you very much for your attention, and I'm looking forward for your questions.
All right, Andres, thank you very much for your pre-recorded poster presentation. The poster is also available on the website. We have time for 1 or 2 questions. Stephanie, you have a question.
Yeah, thank you, Florian. Yeah, I was wondering, you said that the organic system is characterized by a low organic matter input. And so why is it low? Is there no access to organic matter? Is there no labor available? What is the bottleneck here so that the inputs are actually not more consequent, allowing better yields?
Yeah, I think the limitations, thank you for the question, are basically market access and prices. There is access to organic fertilization, mostly guano, brought from the islands of Peru in the coast, but like farmers are not used to buy it to actually incorporate it. So when they do get it and when they do buy it, it's very low.
And there's no
that's basically
cattle.
the only thing that they have.
There's no
Usually
livestock.
the cocoa farms, no, usually the cocoa farms are mainly like only cocoa, so they don't have anything else. Like the only matter is they own like the shells and the other products of the same plantation, and they usually don't compost.
Okay, thank you very much. Unfortunately, we have to move on. Time is short in this session, even though 1 poster is not presented, but we have 2 more to be presented. Thank you again, Andres, for your presentation. And we continue with the next presentation, which is also pre-recorded by Angela Q. Butungi, about land suitability and socioeconomic factors for pigeon pea cultivation in Uganda. And please, all the others, switch off your microphone so that we don't have any additional background music. So I hope that the video will start now. Yes.
Climate change will have drastic changes on the whole world. There is need to identify crops that are resilient to climate change effects. One such crop is pigeon pea (Cajanus caja). However, in Uganda, there is little information about areas suitable for its cultivation and factors that affect its production. Suitability analysis was done by matching land characteristics, that is temperature, rainfall, slope, and soil drainage, with crop requirements using GIS-weighted ovary technique. 283 randomly selected farmers from 3 districts identified from the suitability analysis were interviewed. Our results demonstrated areas suitable for pigeon pea cultivation, and indeed 80% of arable land in Uganda is suitable for pigeon pea cultivation. If we can control challenges faced by farmers like pests and diseases, drought, and lack of improved varieties, then Uganda may escape impacts of climate change on food production.
All right. Angela, thank you very much for the very swift, brief presentation of your poster. We have time for 1 or 2 questions. And again, the Q&A, there is no question showing up. I hope that it works. I'm not too sure about that. But maybe there's 1 or 2 questions here from the other contributors. Any question there? I was wondering, Angela, which soil properties did you consider when evaluating the potential of Ugandan soils for pigeon pea?
We considered the soil drainage, but still we could not be able to use like real data from Uganda. We actually downloaded all the data that we used because it is quite expensive and some data is not reliable.
I thought there is also some African-wide soil mapping going on, which may be useful also for this more valuable than evaluation of the land and suitability for pigeon pea. Yeah, I think there's some work going on, yeah, mapping soil properties on the African scale. Maybe these data can be useful. I think they use a lot of indirect measurements and try to predict properties. Second question, briefly, as there's no question showing up yet by others, what is the benefit for farmers using pigeon pea? Is there a high economic benefit from growing pigeon pea?
Actually, pigeon pea is a multi-purpose crop, and since we are facing climate change where temperatures are likely to rise, pigeon pea is one of the crops that is predicted to be resistant to the drought. And actually, it can be used for several uses. You can use it as food. The stems are used as firewood. It can add manure to the soil, the nitrogen. So it is actually a crop that every farmer would need in their crop in this era of climate change.
All right, Angela, thank you very much. So next time I'm going to Uganda, I'm looking out to and forward to seeing more pigeon peas maybe growing there. So let's see where that goes. And we have our final presentation for today on subsistence farming in the context of food security. And we're going back to Africa. This is a poster presentation from Mozambique by Custodia Matavel, and it's pre-recorded. And after that, we have one or two questions which we can discuss. Okay, let's get the video started.
Dear auditors, my name is Custodio Matavel, and I would like to welcome you to this poster. The title is Can Subsistence Farming Help to Achieve Household Food Security? Evidence from Grui, Central Mozambique. In Mozambique, 1/3 of the population suffer from chronic food insecurity, while 70% live in rural areas and have strong dependence on subsistence agriculture. Nevertheless, 43% of children under the age of 5 are stunted. It is believed that subsistence farming can play an important role in reducing the vulnerability of food insecure households. However, studies on subsistence farming have shown that in general, the households practicing this form of agriculture have a low level of income, and there are big differences in the quantity and quality of food consumed over a year within a household. So the question is, can subsistence farming help households to achieve some level of food security? As an attempt to answer this question, we interviewed 300 households randomly selected in Guru district. Through these interviews, we collected data on socioeconomic characteristics, food consumption patterns throughout the year, and the coping mechanism used in response to food insecurity. And then we used descriptive statistics to analyze data. As expected, our results indicated that the households were mainly headed by male, most without an extra income source, which means they strongly depend on agriculture for their survival. They practice agriculture in relatively small areas with an average size of 1.4 hectares. The results also indicated that the number of households that are able to consume 3 or more meals a day, here used as a proxy for food security, will increase during the harvest season. In the graph, we can see that more than 60% of households are food secure during May, but in January and February, only 5% of the households can consume 3 or more meals a day. So, to cope with food insecurity, farmers mainly use two strategies: crop diversity and food preservation. During a year, they can produce up to 6 crops under intercropping system. However, the problem is there are seasonal differences in terms of the food species they can consume during the year. For the preservation of food, they mainly use open sun drying, which also present some problems as food can get contaminated due to stones, dust, and other materials. And as conclusion, we saw that subsistence farming has many limitations, but the households engaged in this form of agriculture can achieve food security if they use appropriate and innovative food processing techniques. Crop diversity is also an essential mechanism to achieve food security, but more research is needed to improve local practice while addressing the existing threats. Thank you.
All right. Thank you very much, Custodio. We have now 2 minutes left for 1 or 2 questions related to Custodio's presentation. So there is no question on the Q&A session here. Is there a question from the other presenters? Stephanie, yeah, please.
Thank you. Yeah, I'm really interested by the way that you measured the food security, because you looked at it every month, and you allowed to see a differentiation in the seasons, which reminds me of the keynote speaker Helen Young in her talk yesterday morning. So I found that very interesting. So that means that basically it's going fine, except in a moment in the year where it's not fine. And is at that moment, what is the problem? Is that because they are subsistence farmers, they don't have income to palliate, or is it a problem that they cannot store, or what is the cause of this period of hunger of, let's say, 3 months? I think you showed.
Well, thank you for your question. Actually, the problem is during this period, it's kind of growing season for the crops. So, and they have a problem of storage. Of course, as you mentioned, storage is one of the problem. And during these growing seasons, they don't really have enough food. So, at the graph I showed this harvesting season. Actually, it's not a harvesting of only one crop. What they do is producing different crops with different harvest seasons. So in May, they may consume a lot of maize, and then the next month be beans, and then the other month. So that's why we also mentioned that there is seasonal difference in terms they consume, but they do not, as far as I know, produce or harvest any crop during, especially from end of December till February. So that's why this is a hunger period, and they do not have any extra income to somehow buy food.
Thank you very much. I think this also answers the question from the Q&A. The question was, how important is income in achieving food security? Will farmers who produce for themselves be more food secured than those who tend to get more income from farming? You want to further comment on that, or do you think you answered that question as well? Shall I quickly?
Well, of course.
Yes, please.
Of course, income is really important, because, for those farmers who have somehow another form of income, they can afford to buy extra source of food. They will not only help them to have like enough food in terms of quantity, but they can buy another ingredients to somehow increase the food within the household. So income is really, really important, as you mentioned.
There's another question which is related to your talk. What are the criteria for selecting households to be interviewed in your study?
Well, we randomly selected what we had was we went to the extension office. We asked for the list of the household within a certain area, and then we kind of we randomized those names and the households, and we selected them. So we then went to the households after randomly selecting from this list that we had previously.
All right, I hope this answers the question asked by the person in the Q&A. So thank you again, Custodio, for your contribution here. Again, showing the broad range of topics we deal with in many parts of the world. Unfortunately, the time is up and the next session is almost starting in a few minutes. So I want to again thank you all for your contributions. It's nice to see how well this works. I would have loved to continue discussing, and for the next Tropentag, we probably will have a kind of combination of physical presence, Tropentag, with possibilities of bringing people from abroad closer by using these modern technologies. And I'm astonished how well they work. I think they do not work that well at my home all the time, but they seem to work in Mozambique, in Uganda, in Peru. So I appreciated your contributions here and sharing your results and your research and the vivid discussion we had. And I hope to, at some stage, meet you in person, here or there, or at the next Tropentag. So thank you very much again, and enjoy the rest of the Tropentag, however. And have a good day. Thank you.
Many thanks to you too.
You're welcome.
Goodbye
Thank
all.
you very much. Bye.
Thank you. Thank you very much.
Bye.